Well, we're going to look at lesson 5.1 today. So here's your attendance link. If you want to scan that with a phone, if you want to go through, maybe you're on your phone and you need a different way of getting there, what you should do is go to your digital classroom, which I'll just show you from Google Classroom. Power School Learning will work as well. And we'll go to chapter 5, which I guess I can move my chapter 4 down. I don't need this up at the top anymore. We've completed chapter 4. So let me adjust this downward. Almost there. Moves as fast as I can. All right, there we go. So if you go up to chapter 5.1, chapter 5, lesson 5.1, and open that up, that's where we'll be today. The fact that you're listening to me means you've taken care of number 1. You're either here in person, which I have some in person. I have 31 on the Zoom. And later, if you need more help, you can always come through and do it YouTube as well. But you're taking care of number 1 out of the 4 things for each lesson. Number 2, just a reminder, we have to fill out the attendance. So there's another way of getting to this attendance. So even if you don't want to use this link, you can use that number 2 right there to take your attendance. And then after you do that, I would suggest you open up number 3. It'll take you to Power School Learning. If you slide down, you can hit that start exam. Mine says resume because I've already clicked it before. And you will have your problems that we're going to go over today listed here. So I would have that open if I were you. I'd also open up your pre-programmed calculators. That's list. We'll use 2 sets today. I'm going to be using basic right trigonometry quite a bit. So I'll open that one up. And I'll have one problem where I use another. So I'm not going to close this tab just yet, but I will momentarily. All right. Let's take a look at problem number 1. It says find the exact values of the 6 trigonometric functions of theta. So we had rules in chapter 4, specifically on lesson 4.1. I told you if you're solving a triangle, you want to make sure your 2 angles are located where?
On the x-axis.
X-axis, very good. So this is not in the right form. That's on the y-axis. So I rotate it around. And I could solve it like that. And so my 8 has become my y. My 10 has become the hypotenuse. There's my theta. There's my right angle. My x is unknown. So what we could already do, so the reason I wrote up this right triangle trigonometry, I'm not going to use any of this other stuff. I just open that up to have a calculator and also to have the ratios. So I could already find the first of the 6. I know that sine theta is going to be the 8 divided by 10, the y divided by h, 8 divided by 10. And we could simplify that fraction. What number goes both into 8 and 10? 2. So that could simplify to become 4/5. Now I'll let you solve the other 5, but before I do that, let's review how would I find what x is since we don't know what x is right now.
Pythagorean Theorem.
Very good. Very good, Jasmine. So if I use Pythagorean Theorem, whoops, forgot the T there. Pythagorean Theorem, which you learn in, like, I don't know, 7th grade, that it's a squared plus b squared equals c squared. Well, I use x, y's, and h's, so I'm going to say x squared plus y squared will equal our hypotenuse squared. So if I substitute in the values, we have x squared plus 8 squared will equal 10 squared. A little mental math here. Jasmine's spoken up a few times. Tonight I've heard. Let's get someone else. What is 8 squared? 8 times 8?
64.
Very good, Martin. All right, and someone else. What's 10 squared? 10 times 10.
100.
There we go. 100. All right. to solve. And right now I need to get x squared, or x rather, isolated. So the x squared is being added by 64. So the opposite of adding 64 would be to subtract 64. And so we have x squared equals 100 minus 64 is 36. And now what's the opposite of a square to get x isolated?
Square root.
There we go. Now normally in math, anytime you add a square root that's not originally there, you need a plus or minus with it. However, since this is given a real triangles always have positive links. We're only going to take the positive value of 6. And so from there, if you're listening later on and not live, you can just pause your video, but I'll give you a second for everybody else to go solve for your other 5 ratios. All right. Example 2. If sine is 5/13, find the exact values of the 5 remaining trig functions, values of theta. All right, so they've given us one, and we got to find the other 5 this time. I'm going to give us a little triangle to help us out, but before I do so, I'll recommend that we rewrite sine as being y over h. So y over h is 5. Y over h is 5 divided by 13. Now, for those of you who are spatially really good, you could just set up your Pythagorean theorem and go from there. But for others, it might be helpful to have a little diagram. What we know is that we have a positive y value and an h value that's always positive, a 13. We don't know our x, so x can move either way. This problem doesn't tell us anything, so I'm just going to assume it's positive for this visual diagram. So I have 5 units up there. Let's say 1, 2, 3, 4, and 5. So this is a y value of 5. We don't know x, but we do know our triangle has a hypotenuse length of 13. So it needs to be quite a bit longer than 5. So this is not really drawn to scale, but I'm just going to leave it like that. So here's my right angle. And so we'll say h is 13. Now, technically, do I know if it goes to the right or the left? No, I don't. But what we do know is that y is 5 and h is 13. So we go through and do the Pythagorean theorem again. So we have x squared, let me write it over here, x squared plus y squared equals our hypotenuse squared. And so this time the 2 numbers I'm working with is 5 squared. That's so ugly. Let me try it one more time. There we go. 5 squared and 13 squared. All right, mental math time. I've got a 5 squared and a 13 squared. What do we get for 5 squared?
25.
25.
Very good. I heard a lot of 25s there. And what about for 13 squared? A little bit harder. How about 169? And so to solve this, I need to isolate the x, which means I need to subtract 25 to get rid of that plus 25. And so x squared would equal, this is 144. And then again, we take the square root. And this time, since this is not a real diagram, we should have plus or minus. Because my diagram might not be accurate. Maybe this triangle should go left. We don't know that. So it should be plus or minus 12. Now, on the answer choices, I did not add in plus or minuses. So you're just going to use the value positive 12. You'll just assume it to be positive 12. And you can solve for your other 5. And if you're, again, not listening live, just pause the video. You now have the ratios listed here and your diagram there. Just pause the video and get your answer. Let's take a look at example 3. It says if triangle ABC solve triangle ABC if angle A is 33 degrees, B is 9, and C is 13. So let's take a look on this one. We don't know if it's a right triangle or not, but we do know angle A is about 33 degrees. So I'm just going to say somewhere in there roughly. I'm going to represent this as angle A and say this is 33 degrees. B is the short length of 9. Now notice it's not going to be directly across from the A. That would be lower A over here. So I'm going to put B equals 9 right there, which means this will be capital B. And little c, lowercase c, is 13. That's across from capital C there. I'm going to go ahead and connect this. And so now I try to solve this. We don't have a right triangle, so I would not be using right triangle trigonometry. So this is the problem I mentioned, that we're going to use a different calculator. So I'll ask the question, do I have a completed set or a pair? Do I have two A's, two B's, or two C's? No. So if you do not have a pair, what you use is the law of cosines. So law of sines is for it having a pair. Law of cosines, no pair. So here's my values. And so when I open this up, what I need to check out is, or I need to plug in my values here. Capital A is 33. Little b was 9. Little c was 13. A is unknown, so I'll put an X there. Take that off. So the answer should be the intersection, or you could just look right there. The answer should be 7.33, and it says 7.332. You can notice that's the same number right there. So we just solved for little a over here. That's approximately, if I round to the nearest tenth, 7.3. Now, once you know that, you could use law of sines and say, hey, I've got a completed set. And use law of sines to find your next side. Or the other thing you could do, since you're using the calculator, is probably the easiest. And by the way, the algebra, what just happened? Let me back up for a second. The law of cosines is this formula: a squared equals b squared plus c squared minus 2bc times the cosine of capital angle A. So basically what happens, if you need your a, you would take the square root of both sides. So a would be the square root of 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of 33 degrees. That right there is the math that the calculator did to get that number. Which is approximately 7.3. Now, what we could do is to find any other piece, I would just rearrange my formula. For example, if I wanted to find capital B, I would use the formula b squared equals a squared plus c squared minus 2ac times the cosine of capital B. So what I'm doing now, if you look up here, I'm exchanging any a and b that are written out. Any a became a b and any b became an a. Okay, caps for caps, lowercase for lowercase, all the way across. And so how would I do this on my calculator? Well, on my calculator, I'm just going to put the b value in as a. So this a becomes a 9. Instead of this b, I'm going to put in the answer is 7.3. Whoops, 7.3. And this angle A is now unknown. That's what we're looking for. And so the solution here would be, this ends round to the nearest degree, would be about 42 degrees. This right here is 42 degrees. So again, on this one, if you solve this, you would have 9 squared equals, A was 7.3, C is 13, minus 2 times 7.3 times 13 times the cosine of B. And you would go through your algebra to solve that. You'll subtract those two values over, and then you would divide by this front portion and then take the inverse cosine. And you'd come up with that capital B is approximately 42 degrees. Oops, it's just the calculator does it a lot faster than we do. Last part, in any triangle, how many degrees are there in the whole triangle?
180.
180. So a shortcut is to find angle C. C is going to equal 180 minus the 33 degrees of angle A and minus the 42 degrees of angle B. So 180 minus the 33 minus the 42 leaves us with 105 for angle C. And that should be a squiggly because we rounded the B. That's not an exact value. So this will be not an exact value either. So there you have it. That's how you do the bell ringer and review from from chapter 4. So here we go with chapter 5.